All right, so we'll go ahead and get started here. Can I just quick hands real quick? Can I just so I know who I'm talking to, can I understand who are new teams here? Can you guys just raise your hands if you're a brand new team? Okay, cool. Just wanted to give you guys a heads up. This presentation is primarily for new teams. As for everyone else who's not a rookie is gonna basically go through these processes. So, little quick introduction. My name is Matthew. I am one of the programming mentors for Team 930. I have been in FIRST now. This is my 6th season. I'm also a software engineer by trade. So a lot of what I teach my students, the processes, as well as some of the things that we go through through the beginning of the build season, I do in my day-to-day job. And so what I'm primarily focusing on here today is to just teach you guys what we do as programming team at the first week of every build season. And so the biggest thing that you guys are going to have to do is set up your environment. There's a lot of different components that you guys are going to use throughout the build season as a programming team, but also just as a team as a whole. So as you guys have probably heard, and for a lot of the non-rookie teams, as you all know, there's all kinds of different components you're going to put on that robot. Be it motors, be it sensors, be it just things that FIRST are going to give you. And in order for your programming team to actually interact with those different components, there's a whole suite of things you're going to have to install in your environment to actually do that. This process takes our team roughly 2 to 4 days, depending on how much FIRST changes things, depending on how much third-party vendors change things, you're going to come into some problems. So what we have done is we've actually documented a lot of our processes, as well as if you guys do need help with these things, keep in mind we do have a Discord channel and we will gladly help you guys if you guys get yourselves on there. So to kind of start this out, this is our actual website that we use to document everything. It's just a fancy Google Doc. And what we've done is we've mapped out everything that we install week 1. So the first and most important thing that you guys need to install is WPILib. Does everyone understand what a library is, programming wise? Oh, good. Thank God. I don't have to explain that. But essentially, FIRST provides you guys the core library that you will need to actually do, I'm going to say 90% of the development that you're going to need. There are some things that you're not going to get in this package, and those are your third-party vendor things, and we'll go through a couple of them. But there's so many third-party stuff out there, I'm not gonna be able to cover all of them in the 20 to 30 minutes I have to talk to you guys. So the big thing to understand with the WPILib library is it actually has a website, and I guess we put the GitHub on here, not the actual link to the website, which is sad. Can you click on that WPILib installation guide for me? Please take me to the website. Yeah, perfect. Okay, so FIRST has a very nice set of documentation for anything that is FIRST in WPILib. They have a very nice step-to-step instructions on to install not only the library, but all of the third-party, well, I wouldn't say third-party, but the extra tools that you're going to need, which are from National Instruments, to actually integrate with your robot and to do all the testing that you need. And there's documents on everything that you're ever need to actually get through some of this stuff. So the first thing, especially new teams, I would highly recommend you spend a day or two, just go through this documentation. Read it from top to bottom. And if you guys, again, have questions, reach out to Chief Delphi, reach out to us, and we can kind of fill in the gaps. But they do a pretty good job of explaining everything here. Sure. Yes. So, all right, so that's WPILib in a nutshell. This process, just to fair warn you, if you do this on a school network, it can take a couple hours to install this library. It's a pretty hefty piece of software that you have to install, as well as to install the third-party things like your drive station and a few other things. That's a separate thing outside of WPILib. It's all documented in here. Make sure you install that stuff before you start trying to develop and test and do things like that. So that's WPILib. You can go back to our document. Once we get WPILib installed, there are 2 primary third-party vendor software that you guys should install. Even if you don't use the hardware that is associated with them, it's good to have it because most likely you are going to deal with it. The first one is Rev. Show of hands, does everyone know what Rev is? Has everyone heard Rev? Okay, good. So again, Rev is probably the core piece of, or I should say, company that you're going to deal with. Probably 80 to 90% of the hardware that you're going to put on the robot is going to be from Rev. If you need to manage drivers, if you need to calibrate ID, most of those hardwares you have to go through the Rev, um, I guess the Rev tool and the Rev client. So again, they do a pretty decent job of documenting things, but make sure you have the client installed, and then make sure that you install and include the driver libraries inside your project in order to actually use this. So that's Rev. You can go ahead and go back to our site. And then the next one, which until probably last year, whenever we had that shabacle with First and Spark Maxes and things of that nature, if you deal with anything that is Spark, so a lot of your motor controllers and a few of the power distribution hubs, you're going to need to use a tool called Phoenix Tuner. So if you can click on that Phoenix Tuner link for me. This is going to provide the tool that allows you to calibrate a lot of those components, as well as the biggest one is updating drivers. It's a pain. We will gladly help you. I hate it every year that we have to deal with Sparks, but that's what the Phoenix Tuner is for. Make sure you get that on there just to have it. Again, if you don't need it, it's better to have it than not need it. You know what I mean? So that's this. And again, there is a link in here to also how to install it through the actual project, and make sure you guys look that up. So we'll go back from there. And then we go from there to a few of the other key third-party things that we want you guys to think about. Our document's actually a little outdated for the Advantage Scope. So just to fair warn you guys, who here has used Advantage Scope last year? Does everyone know what that is? Okay. Quick rundown. Advantage Scope is it's a piece of software that's created by another team. I don't remember the team off the top of my head. I'm horrible with names and numbers. But Advantage Scope you don't actually have to install anymore this year. It comes with the latest and greatest WPI lib. I highly recommend that you guys look this up and read some of the documentations. It's a logging it's a logging library that allows you to actually simulate what your robot does during competition, as well as you can do some simulation even before you get a robot. It's kind of a cool tool. We started using it last year, and our team was actually able to get the robot to about 80–90% functioning without a robot. So it's a very crucial tool that we started using last year, and we won't go without it anymore. So this is as important because it comes with the WPI lib library. But if you need to get documentation, you can come to this link and go to their documents through their GitHub. So, and then of course, I'm assuming, raise a hand who all has done like autonomous paths. Has everyone done autonomous paths? No? Okay. Well, as you all know, most games, first 15 seconds of the match, you have autonomous. If you want a really cool tool that allows you to actually create autonomous paths, and they come with a pretty nice library that you can incorporate with your code, you can go to Path Planner. The actual software that's outside of your code, you can get through the Microsoft Store now. You don't actually have to go through GitHub, and it actually has a really nice installation process. But Path Planner, we highly recommend to all of you. It's very easy to use. Some of the, I should say, using the tool itself can sometimes be a little confusing, but the documentation is pretty good, and there's a lot of resources out there now. You guys can get help on it. Again, come to us through Discord, and we can easily walk you through it. But highly recommend you install this and then get it incorporated in your code as soon as possible. It becomes a very big key of, at least for us, for our success. So, yep. And then on top of that, you're going to start going through the FRC drive station. So this is the National Instrument stuff that I mentioned earlier. So for most of you probably don't know, National Instruments is another company that works with First. They provide you guys the Rio, the brain of your robot. All of the tools that incorporate you being able to interact with that robot, you have to install through their installer. manager. And it's the biggest thing with this, and this gets us every year. In your kit, you're going to get an envelope that has, it's either a serial key or a, what is it? It's either a serial key or a product key. Make sure you don't lose that because you have to activate it through that. And if you lose it, you do lose some, you can lose some of the free features that they give you for being on first. But make sure you install these, otherwise you can't test your robot altogether. So that's that. And then after that, we get down to just a few things that we installed to go along with the WPI lib. So we use Git for our repo. We highly recommend you guys get Git Bash. It has some really nice command line or features and functions. You can also use, for those who use Linux, you can even do Linux commands in Git Bash, so you don't have to fully be reliant on Windows-based interfaces. But also there is just some, if I remember correctly, some like authentication stuff that they do under the hood that you guys just don't have to worry about. So if you decide to do any kind of security on your repos, this just makes your life 10 times easier. So we always install that in all of our environments. And then from there, you're basically, what we focus on once we get this environment built up, and again, sometimes it takes us 2 or 3 days because we go from previous years, so a lot of times we either have to blow our environments away or we have compatibility or upgrade issues. For new teams, you guys won't have to worry about this. You should be starting from scratch. But once you get through that, we then typically spend 1 to 2 days going through and updating all of our hardware. So you're going to typically use the clients that you installed, so like Phoenix Tuner and the Rev client, but also sometimes we have to go in and actually get updated libraries to be put into our project, and all their websites have links to those. We could probably show you, I can't show you guys how to update the libraries because we don't have code on that laptop, but again, if that's something that you guys need some guidance with or help, we can easily show you how to do that. Other than that, a lot of our programming team, we participate, just like what they said in the previous presentation, a lot of the prototyping. But then we also, based on our prototyping, we look at our previous years and we try to figure out what kind of components are we going to need to write our code for. And then we kind of start planning that out for the rest of the build season. Our team, we divvy up our programming teams in about three sub teams, and we essentially try to divvy up the work as much as we can to do as much parallelism as possible. I don't know about all the other non-rookie teams in here, but we typically do not get the robot until like 4 or 5 weeks into the build season. So we try to get as much done as we possibly can before we actually get the robot. And one of the things that we do, and do you still have the WPI lib link open? Probably, yeah, that one with there, yeah. Is there a search at the top real quick? Go up to the top, on the side there to the left. Scroll, yeah, hit the search and do simulation. One of the things that our team is pretty known for here in Wisconsin is we can pretty much simulate 95% of the robot, and we typically simulate all of it within the first 2 weeks of the build season. By doing this, what we can do, so if you go to that robot simulation, yeah, I got it right there. What this allows you to do is you can actually completely compile your code, run in a simulated environment, and you can actually play with mocked hardware that you would see on your robot, and you can actually see how your components kind of work together. So typically what we do is, besides planning on the components, we also figure out how are we going to simulate this? What are some of the things that we need to do to actually start playing with these things without a robot? So our first week is a lot of planning. We spend probably 2 to 3 days literally just brainstorming what is it that we're going to do, and we figure out exactly what we're going to simulate and start kind of getting that environment set up. Now, simulation can be kind of tricky because nice thing about WPI Lib is a lot of it's integrated for you, so just building your project will actually simulate a lot of it for you automatically, but it's learning the tool. So if you can click on the introduction to robot simulation real quick, let's see if they show you a picture. So if you scroll down, okay, keep going down, keep going down. all the way down. Come on. Okay, yeah, actually, you just passed it right there. So whenever you guys go to build your code and you hit the little W at the top right corner of the IDE, there's an option that you can type in for simulate robot, and it will actually go through and compile and convert a lot of your physical components into a simulated mocked environment. And in here, if once you get done with that, you can actually, if you click on the WPILib simulation GUI, that little link right there underneath the picture, right there for me, thank you. If you scroll down, this should show us hopefully a representation. Yeah, this guy will pop up. The hardest thing about simulation nowadays is just figuring out how to use this tool, okay? I would highly recommend for your first week, again, there's practice projects out there you can quickly generate. You don't have to create anything from scratch to start testing and playing with these things. I would highly recommend you go through this documentation and just bang on this GUI. This GUI is so helpful. You guys have no idea how much work as programmers you can get done in literally half the time that it took us probably 5 years ago to get programming done. Typically, we can have functioning code to probably around a 70% capacity of what we expect before even having a robot. Simulation, to keep in the back of your minds, you can't simulate a lot of the real world things. So if motors start not interacting with each other right, or friction when it comes to the ground to wheel movement and how those things interact, you can't simulate that stuff here. But you can at least make sure all of your functionality is working as expected. You can just make sure that things interact appropriately. So we use command-based. A lot of times when you're making commands, you're not always thinking about how does one command overlap another. This allows you to kind of see that as you're developing. On top of that, for those who don't know, so we use Java. Does everyone use Java in here for your code? Okay. Does anyone use C++? Just curious. Ah, dang it. Okay. Anyways, I'm a C++ developer. Anyways. You were thinking about doing C++. What's the recommendation? I would do Java, just because there's more support for it in the first community, and there's just a lot more examples. I think maybe 10-15% of the teams use C++, and so you're just not going to have a lot of examples out there. So just something to think about. Also, the kids don't have to think about as much with the Java when it comes to management and the memory side of things, pointers and things of that nature when you use Java. So, but with the whenever you're developing and you're trying to write code, what's really cool about this is there's a lot of infrastructure that you can easily get access to do things like mock stuff. And on top of that, Java typically, when it comes to debugging, is very difficult because it's an interpreted language. So you typically have to run your code in order to actually debug your code to some extent. This comes with a pre-installed debugger. So you can actually breakpoint your code. You can actually step through. You can see the call stack. You can see all that stuff that you typically get free in a C++ compiler. You don't always get free in a Java environment. So that's another good reason why I recommend you guys spend some time on this. And again, we have workshops on how to debug, how to simulate, and we'll easily help any team who asks in the Bare Bytes. We do this stuff all the time. Essentially my little thing here is a little bit more open form than all of the other workshops. I wanted to give you guys just a high level of what we do in the first week, but I also want to give you guys a chance to talk to me, a programmer, because a lot of times what we see, especially with rookie teams, is the programming side of things is the scary part. No one likes it. No one typically knows about it. And so we just want to give you guys the platform and the resources to kind of help get you through that initial hurdle and scare of programming. I promise you, programming is not as scary as what it looks. And there's a lot more resources out there. And there's a lot of teams out here, especially in the Wisconsin environment, that will gladly help you, and we are one of them. So that's essentially what I wanted to go over today, but I also wanted to kind of leave this as like an open forum for you guys to ask questions. And so I'm going to go ahead and just kind of leave it open here if there's any questions that you guys might have about this stuff. Anything? I think we only have like one new team here, so we were hoping to have two. I thought we were going to have two rookie teams here today, but any other questions for me? Sure.
Partly just because we missed the very beginning. What's the rev?
The Rev client. So if you buy anything hardware through Rev and you need to manage, you know, you need to manage hardware, you need to update that hardware, or you need to tune it, you need to ID those type of things, you got to use the Rev client to actually do those things. The other nice thing is if you're having some issues, and we've actually used it for debugging, especially the CAN. If you have problems with CAN, that thing will help you actually figure out where you might have issues in the CAN bus, more so than you will see through like your source code.
What's CAN?
CAN, so that's the communication line that typically you're going to put most of your motors on. There's two types of CAN now that you can use. There's a CAN-A4, which is a network-based CAN bus, and then you have the old school like electrical wire CAN type of platform. I'm not a hardware person. I just know the high level of the two different types of cans that you can have. But the CAN-A4 is a lot easier to debug because it's over the Ethernet. There's actually we've learned this off season that there is actually some built-in mechanisms that help you find issues in that a lot quicker than the traditional CAN bus. So we highly recommend that you guys look at the CAN-A4. The only problem with the CAN-A4 is there's a limited number of devices that actually support it, and it's a whole separate type of platform. So there's a whole different configuration you have to do on the robot to actually get that working. So, yeah.
Is camera useful in FRC game?
Say that again?
Camera.
The camera? Yep. So there's a couple different cameras that we've been trying to use over the course of the last couple of years. So you have the Photon Vision, which is a Raspberry Pi based camera, and then the most common one is Limelight. I would highly recommend going with Limelight. There's a lot more pre-built in software. It's a little easier to use. There's less on the developer side when it comes to get that up and going. And we also noticed that there's just a lot more nicer features in the Limelight. You're going to spend a little bit more money. Those Limelights, you're going to spend $250 to $300 a camera. Yeah. I guess another good thing to note about cameras we learned last year, power is everything. So making sure you have a constant source of power to those cameras is key to having those work. So think about how you might manage power to those cameras. We had a lot of issues with cameras losing power because of how much draw we were pulling on the system.
Maybe just to turn power on quicker.
Yeah. Well, a lot of those, like the Raspberry Pis, have a built-in safety in the hardware that if they drop below a certain amperage, they just completely shut off. And we were actually having cameras completely shutting off during matches because we weren't having consistent power go into those cameras. So, and cameras and vision is probably going to be a big key. Also note, make sure everyone knows, reflective tape is gone. It's not here anymore. So you have to, if you're going to use cameras, yeah, you're going to have to learn how to use April tags, which are the new mechanism.
How would you recommend starting off with using April tags?
Sure. So what's really cool about April tags is WPI-Lib actually has provided a whole nother infrastructure around April tags. So read the documentation in WPI-Lib. They have a whole set of libraries that you get to use, interfaces to actually interact with the camera. But then the biggest thing is, we got to figure out what IDs they're going to be using and what are the actual April tags for the game. And we imagine that FIRST is going to release those today along with the game. So make sure you get those downloaded, get them printed. Make sure they're up to size that is specified in the actual game manual. If you make those smaller or too large, it will completely throw off all your calibration and testing.
Do you have a link for how to use the camera in your website?
We might actually, in our documentation, in our source code section, we should have a camera section. So we have Advantage Kit, Path Planner, cameras. Yeah, we have a whole camera section. So if you go to the far left of the screen, yep.
Okay.
So, and we have documented everything we've done over the last year. This is getting updated. We've done a whole new document scheme this off season. So this might not be 100% complete, but it will be complete within the first week.
I've got another question about April.
Sure. Yeah, reflections are the big one. We had a lot of teams last year. We would get it working, especially us. We got it working in our actual shop, but we don't have all the actual plastic pieces for a lot of the targets and things of that nature. We got to competitions and we found that reflection actually completely skews the entire algorithm when it captures the tags. So if you guys want to accurately test for April tags, put a lot of reflective surfaces on your test environments just so that you can get over that hurdle. We also saw lighting played a huge role. So getting down a process of calibrating those cameras during calibration time at the beginning of each competition is key to actually having that as accurate as possible. So those are the two big things. Other than power, we found we had 3 cameras on the robot. We were pulling so much draw and we had cameras in the wrong place in our power distribution hub to the point where they just weren't getting consistent power. We were actually corrupting our cameras because constantly having loss of power actually corrupted the install on the camera. So we're hoping this year stuff has gotten a little bit more stable because last year was the first year that got implemented. But you know, you're going to still probably have some growing pains since it's only the second year that it's been implemented. So.
So how did you route the power percentage?
So we think we have a solution this year. We've been kind of brainstorming ideas this offseason. We never fixed it for last year. We end up just not using it towards the end of the year.
My mind is going towards like supercapacitors.
So buck boosting, creating, and also we learned that the PDH, the power distribution hub, the closer you put your more power starving items to the front of the grid, so the first and second position, you're more guaranteed consistent power. If you put things towards the back of the PDH, which is what we did with our cameras, everything else actually weakens the power to those last few ports in the PDH we learned this off season. So anything that requires a consistent power, put it towards the front of that grid on your PDH. Otherwise, yeah. So put your drivetrain towards the end because that's typically the most taxing on your power grid on your robot. So yeah, good questions. Any other questions? We have a couple more minutes. This was what I was hoping. So. Oh, sorry.
You said your robot uses 3 cameras. Do you guys have any bandwidth issues getting 3 camera streams?
No, because basically what's being sent around the network table is essentially just a point. So it's a very small packet that's getting sent across. Now, if you're going to try to stream the actual visualization of those cameras, all 3 of them, yes, you will have a bandwidth problem. Highly don't recommend you do that. Some teams were streaming at least one of their video feeds to help with driving on the field, but it depends on what your need is. But yeah. Any other questions? That's fantastic questions, guys. I like it. Awesome. Well, this is pretty much what I had. Did we have one more hand up? Sorry.
What situations have April tags really been helpful and useful?
Yeah, so we use it to improve our odometry. So basically, as the robot is driving, the idea is the moment it sees an April tag, it uses that to add a more accurate position of the robot on the field inside your odometry. And then it basically corrects any kind of, what's the word I'm looking for, shifting or phasing of your odometry. So over time, your odometry becomes less and less accurate the more it's running because it's based on the magnetic field of the world, meaning it's just going to shift. So that's one major piece, but then you can also, we've learned this off season, we actually have it using it to actually drive to specific positions on the field. And you can actually use it to help you align to your target. It also really comes down to how does FIRST implement the April tags. We felt like last year's game, they could have used more. It was not what we expected. And I think that also played a role in how many teams really invested into it last year. So we're hoping after feedback and everything, we see more April tags on the field because that really plays a role on how much it can be helpful during the game. So we have time for one more. What are April tags? So I could spend an entire hour, 2 hours talking about it. We have a whole.
I'm picturing QR codes.
It's exactly what it is. It's a QR code that basically, when the system reads it, it returns a number. FIRST has provided in the WPI lib an entire inner infrastructure around those numbers. So if you feed it a number, it will tell you a position where that QR code sits on the field. You could then use that, depending on how you want to use it, to figure out where you are on the field, and then you can feed it into whatever you want to do whatever you want to. You can do things automatically, or again, we use it to correct our odometry. So, but there's a whole math behind it. We do have a website. We do have a workshop that we did last year on this, so we can get you that if you want it to help you guys learn it. Okay? Well, it's 10:30, so we're going to call here. Thank you guys so much for your time.
The awards are